Okay, my thesis is about a problem that your brain faces each and every day. Every morning you walk out into the world and encounter hundreds of faces. Each of these faces contains a wealth of information that must be processed nearly instantaneously. For example, what is this person's identity? What are they feeling right now? What are their intentions towards me? If your answers to these questions are slow or inappropriate, the consequences could range from an awkward situation to a serious altercation. So for these reasons, you might imagine that humans are pretty good at face perception. And you wouldn't be alone, but the reality is a lot more complicated. It turns out that variation in things like viewpoint, lighting, and expression make identification of anyone that you're not personally familiar with a surprisingly difficult task. I've illustrated this at the top of my slide, where I'd ask you to identify that individual from the lineup of 10 faces to the right. If you're anything like the general population, this is quite a difficult task, and the answer, by the way, is number 6. So for my thesis, I wanted to explore what makes some individuals better at face identification than others. And to do this, I went looking for the most useful source of information available in a face. And when I say useful, I mean some information that is robust to these changes in viewpoint and lighting that I described a moment ago. I also wanted to make sure this information is biologically plausible, meaning that given what we know about the neuroscience of visual perception, is it actually likely that the brain uses this information during these tasks? One candidate source of information that satisfied both of these requirements was the orientation structure in the face. We've long since known that the visual system deconstructs natural images into their component orientations. And when we applied that same transformation to face images, as I've done here, the results were extremely compelling. Here I've broken down this face, these two faces, into two equal sources of information, the horizontal and the vertical. And what you can see is the two vertical images on the right look nearly identical to each other, despite the fact that they have a lot of structure, whereas the horizontal images look quite distinct. This suggests to us that it is the horizontal band that you actually need to identify faces. And our most exciting result is that individual differences in how well you use this horizontal band actually predict your accuracy on everyday face identification tasks. This tells us that we really have zeroed in on the source of information that makes some individuals better than others. These results have some fantastic implications. There's a variety of disorders that disrupt normal face processing, like autism, schizophrenia, even just healthy aging. And with these results, we could begin to develop targeted training programs to improve the source of the deficits experienced by these individuals and actually improve their day-to-day lives. We might also start to think about computer vision applications. And to give you a taste of what I mean, in the bottom right of my slide, you can see that we can deconstruct this horizontal structure into a unique identity barcode that represents you and can be used in a variety of computer vision applications. These are just a couple of the exciting results in my thesis that I think pretty convincingly show that horizontal structure underlies human face identification. Thank you.